Hi, welcome back to Math with Rhyme or Reason. Today I'm going to do the second part of solving quadratic equations, and that's solving by using completing the square. We're going to need this when we are working with parabolas in order to get them from this form into a form that we can easily graph and work with. So the first thing you'll notice with this one is it's not factorable. My go-to is solving by factoring, but if I can't, then I'll use either completing the square or use the quadratic formula, which I'll show you about in the next video. So, solving by completing the square. There's a couple ways to do this. I'm going to show you what works well for me, and as far as, again, setting you up for dealing with parabolas next. So the first thing I'm going to do is I am going to ignore this. I'm going to move the plus 3 over out of the way, as it were. Okay. Now what I'm going to do is I am going to split this guy. What I'm going to do is create a perfect square. So in order to do that, I have to get from this format into a different format. And how I'm going to do that is I'm going to take this and divide it by 2, so that makes minus 4. And then I'm going to square it. I'll do this in a different color so that you can see what I'm doing here. So I'm going to say plus 16. Now because I've added 16 to the equation, I have to subtract 16 so that I've netted 0. That is, I don't change the equation at all. This just adds to 0. Okay? So now what I've done, though, is if you look at this section right here, I've created a factorable and in fact a perfect square. This factors to this, all right? In other words, if I were to take x minus 4 times x minus 4 and multiply that out, I would get back what I have in the green parentheses, all right? So what I've done is I've created a perfect square by adding the 16. And I'm going to show you why I use that here in just a minute. Now the negative 16 plus 3 becomes negative 13. And it still equals 0. All right, so now if I want to solve for x, if I want to isolate x, what I'm going to do is I'm going to add 13 to both sides. And then I'm going to square root both sides. Now when I square root both sides, I have to worry about the positive and negative result. I'll show you what I mean. All right, so the square root and square are inverse functions. They undo each other. And so I get x minus 4 on the left side. On the right side, I get the square root of 13. But I also have to worry about the positive and negative part to that. All right, that's what I meant a minute ago. So when you square root it, you have to have the positive and the negative, because if I were to square root, say, x squared equals 9, and I was solving for x could be either positive 3 or negative 3. So I have to worry about both in this case. Now to finish off my equation, I'm just going to add 4 to both sides. So I get x is equal to 4 plus or minus square root of 13. Now remember, we're looking for 2 roots because we're degree 2. So those are the 2 roots. There's 4 plus root 13 and 4 minus root 13. The other thing to keep an eye out for is sometimes you can simplify this radical. In this case I can't because 13 is prime, so I'm done. My 2 answers are 4 plus root 13 and 4 minus root 13. Okay, let's try another example. Okay, on this example, I kind of upped the ante a notch because I'm going to make the second term of my equation not even. That is, I'm going to have to work with fractions here in just a minute, and that's okay. So I wanted to do one of those so that you could see a more difficult example. I'm going to pull the same stunt. So I'm going to move the 2 out of the way a little bit. And like before, I'm going to half the 5. This is when fractions are really nice, not decimals. So I'm going to half the 5, and I'm going to square it. And because I've added 25/4, I'm going to subtract 25/4. I'm just going to move my 2 over a little bit here, so that my net change to my equation is still 0. Okay, and again, I've created a perfect square right here. Okay, keep that same sign. So this will be x plus 5/2 squared, and that replaces the green bracket here. In order to facilitate my fractions, I'm going to change this to a negative 8/4 in my head. So I'll just write it there so all I did was get common denominators, right? So that gives me then negative 25 minus 8 is negative 33/4, and that equals 0. Okay, now I'm going to add the 33/4 to both sides. I'm just going to move the eraser here. And I'm going to square root both sides. And again, that's going to create my 2 answers right there. I'm just going to continue on over here to the right, okay? So I get x plus 5/2 because the square root and square root undo each other. And over here, I get the square root of 33/2. And what I'm doing is I'm simplifying that radical straight away. So that's the same thing as the square root of 33 over the square root of 4. The square root of 4, of course, is 2. And I'm going to not forget my plus or minus. Put that in there. All right. And now I'm going to subtract my 5/2 from both sides. And since they have the same denominator, I'm going to go ahead and write it all in one fraction. You can leave it as 2 fractions as well. So I could have negative 5/2 plus or minus root 33/2. But since they have the same denominator, I might as well make it one fraction. So that's a little bit more complicated example, but I wanted to make sure we saw one that had fractions in it. Okay. Now the third example, I'm going to make sure there's a coefficient in front of the x squared.